In this presentation, we're going to talk about the SRAM solver diagnostic messages. In particular, message BE117, which refers to a section's moment of inertia about the z-axis. This also relates to messages BE115 and 116, which are related to moment of inertia around x and y-axis, respectively. This video is a part of a series of videos that focuses on solver diagnostic messages. If you are not familiar to this topic, we have a separate video with a proper introduction to this subject. We're going to study this model you see here, a wooden platform with steel beams, but for now, we're just going to work an example with just the beams supporting the platform. Let's see. And here's the platform model, just showing the steel beams. I have a steel section and I-beam. Material properties I'm using is steel material, and the supports show that it's fixed to the wall. If I go to the loads window, one vertical point load, and if I display this load, I can see it's 200 kilonewtons at the edge of these beam elements in the negative z direction. And this is because my manager is interested in knowing the reactions and deflections at these points. Now let's say that I run an analysis for the load case I have, linear static analysis, and I see a couple of messages in the solver. Two FYI messages, one BE117, moment of inertia about z-axis is 0, and FYI SL003, rigid body motion mode. Let's not focus on this for now, so let's say that I move on and hit enter. And when I come to the results, if I see the deflection tool, I see the set deflection, and I display this value. Just let me hide the joint load. I see some reasonable values, about 4 millimeters in the Z direction. Results seem okay, and I finish for now. Now, let's imagine that I go for holidays for 2 weeks, and I close this model. So once I come back, I open my model, and my manager asked me to see the response reactions and deflections for the structure subjected to a horizontal load in the x direction. So I go to the loads window, and in this case, I just need to find a new load. So this is going to be a horizontal point load, and I click OK. And I need to assign the point load that was instructed by my manager. It's about 5 kilonewton in the x direction for these two nodes. And I proceed to run the analysis for this case. So no surprises here. I'm still getting the same diagnostic messages, which I never addressed before because results made sense to me. When I go to see the deflections for this horizontal load, and I just need to display the ones in X, I see some massive value, which doesn't make too much sense. And then I go back to my first load case and see the values in Z, which are still the same, meaning that the structure is unstable in the other direction. So now I just focus my attention on that particular message. I remember it said that moment of inertia around Z is 0. So if I go to the spreadsheets and go to my section, I can see that indeed I have a 0 moment of inertia when I defined my steel beam. Perhaps the steel database didn't include this information, or maybe the user simply forgot to define it. I just need to add a value. Let's add 1.5 times this value I have here for y. So it will be around this value. I still getting the other message, the SL003, but I just want to focus on the first message I saw, the moment of our z-axis inertia being 0. But in this occasion, once I run my analysis again, I see that I have addressed both messages. There's no instability showing anymore. And I go to my graphical results, and when I see the values for deflection in Z, I still see it is about 4 millimeters, and in X, if we move to the horizontal point load, it's around 5.5 millimeters. So the lesson I would like to stress and that we learned today is we should always clean all solver diagnostic messages the first time we encounter them. Even if we are getting expected results, we should clean these messages the solver told me to do 2 weeks ago when I defined the first load case. The other lesson is the sequence in which the messages appear. For example, you notice the instability message was the second message appearing, but when I addressed the first one, it got rid of this instability message. So we should go always and fix that first message. Thank you for watching, and for more tutorials and videos, please subscribe to our YouTube channel.